draw the column and table. Okay. So let me just write. What is it? This is unknown. Okay. So this is 2. This is 2, and then this is unknown, and then what else? What else? You have this is 2. This is 11, and then 500. So let me put it here. 500.
20.
20. Where is the 20? 20 is maybe somewhere here. Okay, so you don't have this part, right? You don't have this part. You don't have this part. So this is your F. Okay, so the first thing you have to do, you have to compute the degree of freedoms, right? Oh, degree of freedom is somewhere here. Where is the degree? This is the degree of freedom. Okay, so how to compute degree of freedom? Tell me. The total is 11. You have 2. The missing part is? How to find
11 minus 2.
11 minus 2. Thank you. So the degree of freedom is 11 minus 2. So you should get the value of?
9.
9. So you get 9 here. So the next steps?
Sum of square for error SSE.
Okay, so you also have to compute somewhere here, which is some square error, right? Some square error. So how to compute this part? You have 9, you have 20. So how to find this value?
Unknown divided by 9 equals 20. So
Okay, so the x may be divided by 9,
yes,
and then you will get 20, isn't it? This is the formula,
yes.
right? So how to get it? So basically just put this 9 multiplied with 20, so you will get the value of x, right? So x is
Yes.
9 multiplied with 20. So what is the value? 9 multiplied with 20?
180.
180. Is that correct?
Yes.
180.
Yes, madam.
If you want to double check whether it is correct or not, so try 180 divided with 9. So if you get 20, then that's correct. So now you have 180. What's next?
SS total.
So
Sum of
this is the
square for
total,
treatment.
right? The total is 500. And then you have 180. So can you find this area?
Yes.
So how? 500
Minus
180.
180. So what will you get here?
320.
320. So 320 is here. So you have the degree of freedoms too. Can you find this area?
Yes.
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 So 320, what should I do? Divide, minus, multiply, plus?
Divide.
Divide 2.
Divide 2, you should get the value of
160.
160. So can we find the F here?
Yes.
Yes.
So how to find the F? What is the formula for F?
160 divided
MST.
by 20.
What is the formula for F? Tell me the formula.
MST divided
MST
by
divided by
MSE.
MST.
What? I cannot hear. What is the formula for F? MSE?
MST divided by MSE.
Okay. MST. MST divided with MSE, isn't it? Because I don't memorize your formula. So what is the value for MST? This is supposed to be mean square. So this is T, mean square treatment. This is E, mean square error. So what is the formula for MST? 1. What is the value for MST?
160.
160 divided with
20.
20. So you should get
20.
the value of F. What is it?
8.
8.
8. Okay, that is your F. So this is for section 5. So this should take less than 5 minutes. So let's see the question for section 6. I don't know how is it. So section 6. Let me open a new blank sheet. Okay. Oh wow. It will take a bit of time. Where is it? Quick. What happened? Okay, cool. So where is this is your group, right? So 6. Let me open 6. Okay, so well, the question look very similar, but maybe the blank space are in different part. Okay, so now let's draw the table. So you have like here the sources, so sum squared treatment, sum squared error. So this is like sum squared. This is the degree of freedom. So this is, I don't know, this is empty, this is blank, and this is also blank. And then you're gonna have the total somewhere here, which is 500, and then this is also missing. And then you're gonna have 9, you're gonna have 11, and you're gonna have 120. And then the last one is, this is mean squared. The last one is your F, which is this area, this part. Okay, so how to solve it? What should I do? So the same thing. The first thing is that your degree of freedom, right? Degree of freedom 11 minus 9, right? 11 minus 9, you should get the value of 2. So 2 here. So you have 2, you have 120. So what should we do with these two?
2.
Multiply by 2.
Divided by 2. Divided by 2.
Multiply with 2.
Because the formula for this sum squared treatment here, definitely this divided with 2. Okay, so this x divided with 2, you should get the value of 120, right? So this is missing. So definitely how to find x? So this multiply. So 2 multiply with 120, you should get the value of what?
240.
240.
Yes. So x 240. So let me put it here, 240. So now you have 240 here, and then the total is 500. Can you compute this? Of course.
Yes.
Just 500 minus 240, right? So you should get the value of
260.
Now you have 260 and then you have 9. Can you compute this area?
Yes.
Just divide it.
3 divided with 9. So you should get the value of, well, 28 point, should we make it to decimal or maybe 3? Okay, make it just 1, okay? Okay, so 9. That's fine. You can maintain 2 decimal, you can maintain 3 or 4. I'll just, for simplicity purposes, I will put 1 decimal. Okay, now, so can you compute F? So, of course, what is the formula of F? F, the MST over MSE. This is MST, this is MSE. So, what is the value? 120 divided with 28.9. You should get the value of what? 4.15 something if you want to make it whatever decimal point. Okay. Okay. Is that clear to everyone? Should be easy, right? Okay. Any question?
Yes.
Any question? No?
No, madam.
Okay, cool. Okay, well, the second table looks better than the first one. The first looked terrible. That's fine. So now, let's look at the morning class question. I don't know which one is easier. What is this? Okay. Let me see. We reached the morning class. Okay, this one. Okay, so let's look at the question. I'm assuming that the level of difficulty should be the same. Okay. Okay, so let's read and try to answer this question together. Okay, because you have studied the chapter, so you should know about it. Okay. As a statistics, I'm assuming that you can see my screen, the question clearly. Okay. As a statistics students, you want to compare the variation. Okay, when you look at this word variation, of course, you have to use ANOVA. So when you have what we call test 2 later on, it is like a combination of a few chapters. So you have to decide, you have to use your discretion, what kind of test, what kind of formula should you use. So you have to be able to identify what is the keywords. So when we talk about variation, definitely we are talking about ANOVA. Remember, ANOVA is analysis of variance. Okay. So yeah, you want to compare the variations in the selling price of houses that were not affected by flood with the affected one. So here you have two things. So, but we are talking about variation. So make sure that you are not confused two things here with two sample tests. Okay. Because previously you are talking about two sample tests, you are comparing two things in terms of the mean only. You are not comparing in terms of variation. Okay, so two sample tests cannot compare the variation. Only ANOVA can compare variation. And on top of that, ANOVA can also compare the means for more than two means. Like if let's say you have 3 means, 4 means, whatever, how many hundreds means, only ANOVA can use that. Two sample cannot compare that. Okay, two sample can only compare two things in terms of their means. And one sample just talking about the means of one thing. Okay, remember that. Because I discovered that because when you have so many chapters cover in the test, you get confused. You are using the formula for two sample because you saw like those who are affected by flood and not affected. So you get confused. But look at the keywords, it is variation. So ANOVA. Samples of, okay, what is this? The samples of 21s of non-affected. What is that? What is that 21?
N.
Okay, this is the N for first sample. Remember, you have two things, right? Houses, the housing price for affected and not affected by flood. So this is the N1, which is 21. Okay, 21s of non-affected houses sold within the last year reveal the standard deviations of the selling prices was 45,000 plus. So what is that 45,000? What is that? That is the standard deviation, right? Because they clearly mention the standard deviation here. So you should know how to transform these words into the symbol. Okay, and samples of 18 affected houses. This is another house. The previous one is not affected by flood. This is the affected one. So what is the N? What is the N? I wanted to say what is the 18? So this is your N2, which is 18. Also sold within the last year revealed that the standard deviation, so this is the sigma, which is the sigma, this is sigma for sample 1, this is sigma for sample 2. Okay, so you have to label them properly or else you will mix them up and then you will get confused. Okay, this is the sigma for sample 2. What is the value? 21,330 at the 0.01 significance level. Okay, so what is this 0.01? This is your alpha. Okay, so can you compute the test statistics? Is this question ask you to solve all the problem?
No.
No, so just answer the question straight away. I mean, when you have the all these things, when you read them, make sure that you read the question. If let's say they ask you, can you means that if let's say they ask you to solve the problem, then you solve it. But in this case, they only ask you to compute the test statistic. You know that hypothesis has 6 steps, but in this case, they only want you to solve one step in the hypothesis, which is step number 3, test statistics. Okay, so in the case of ANOVA, what kind of test should we use? Should we use t-test, whatever test? What kind of test should we use in ANOVA?
F.
F. Okay, remember. You have how many tests have you learned so far?
3.
What are they?
Z, T, and F.
Yes, we have D, T, and F. So now in ANOVA, you have to use F. So what is the formula for F statistics? Do you remember?
Yep.
So, okay.
Stigma
So-
square 1
Yeah.
over stigma square 2.
Okay, cool. Basically, instead of putting this sigma, because if you look at the question, it is a sample. So the right side should be S1 instead of
Yes.
sigma. Yeah, so yeah. But well, that's fine because it will not change anything. Okay, so let me just also change the, okay, where is it? Okay, so, oh, where is my, okay, so in this case, instead of putting here sigma, so I will put S1 squared over S2 squared. So 1 here means that sample 1, and then you have squared means that instead of saying this is your standard deviation, this refers to variance. So variance in sample 1 over variance in sample 2. Okay, when you have squared, then it refers to variance. Okay, so now can you compute the F statistics? So what is the question give you the standard deviation, right? So 45,600 over 21,330. Is that all? Is there anything missing? Is that all? Can we just compute it? You have to put square to make sure that you are computing the variance. So if you have squared, I don't know, what will you get based on this working? 45,600 squared, and then you're going to divide with 21. What? You will get 4.57. Yeah, so this is the F values. So is it easy? Yeah, it is very straightforward.
Yeah.
Which one is easier, yours or theirs?
Yes.
Yeah.
I think both are the same level of difficulty, should be easy. Okay, so well, for the other parts, the other sections is also similar. I mean, well, the same thing. They are given the standard deviations, and then everything is there. Yeah, the same thing. Okay, so I don't think that I have to explain the second part. So let me see. Because when they answer this question, they ask me so many things. Okay, so let me see. Okay, so this is, I hope that you can see the whole thing. Okay, so this is the real question. Okay, instead of just compute the test statistic, of course the question will not ask you something simple like this. They will ask you at the 0.01 significance level, can we conclude that? You can see that the question asks you to solve the problems. Means that you have to derive all the 6 steps of hypothesis. Can we conclude that there is more variations in the selling price of non-affected houses compared to the affected? Okay, even though they didn't put compared, but you are comparing two things, right? Non-affected with the affected. Okay, so well, yeah, you have this hypothesis, right? I mean, okay, let's should we discuss here? Do you want me to write a new one? Which one is better? Okay, no one's saying anything. Okay, so let me just write it here. So first steps, you have to write your H0 and H1. So this question asks about what? Can we conclude that there is more variation? So this is the keywords in the selling price of none. So whatever, because we are talking about variation. So you have to put is there, you can put sigma, you can use S as a sample variance. So variance in what sample 1 is more than the variance in sample 2. Or you can also define what is the sample 1. Sample 1, because if you look at this question, it is the non-affected house. This is the sample 1. So you can also write, if let's say you don't know, you can say there is more. Well, you can write more in full, more variation in what? In the selling price of non-affected house. In selling price of the non-affected houses with the affected one. Okay, you can write it in full. That's fine. I just want to see the words more to show that it is like one sample. And then what is the point that you wanted to show is variation, which is your variance, right? Okay, so H null is just the opposite. So you can just write variance in sample 1 should be smaller or bigger than the variance in sample 2. That's it. Okay, make sure that you have mastered on how to write your first steps in hypothesis testing. Okay, because everything, all the points should be given in the question. Your task is just to transform them into this kind of words. Okay, and then the same thing, you have alpha 0.01, and then number 3, you have computed your F statistic, right? So I will skip this. Number 4. Okay, what is number 4? CV. So okay, tell me how to compute the CV. Anyone?
Go to F table.
You have a yes, you have a few steps, right? Let me show you. So basically, you have to go to F table. Okay. So if let's say you are talking about two-tail, so you have to divide it with 2 to reflect that it is two-tail. But here, is it two-tail or one-tail?
One tail.
Yeah. So you don't have to divide with anything. And then look at the degree of freedoms of numerator and denominator, and then you will get the value of CV. So let's look at the table together, because F statistics is a new table. So some of you may not be familiar with it. Even in the morning class, they ask me, what is the difference between the tables and blah, blah, blah. So I think it's better to look at it together. Okay. Scroll. Okay. So before that F statistics, yeah, you will see chi-square table. We will learn it in the next chapter. Okay. And then you will see this is F distribution, like F statistics. But then 5% level of significance. So for F table, you're going to have 2. One is 5%, and the second one is 1%. Which table should we use? We have 2 tables here. So look at the question. What is the question? It says that at the 1% significant level. So which table? You have to refer to 1%, of course. So now you are in the right table. So how to find the value? Because you have degree of freedoms for numerator, degree of freedoms for denominator. So how to look at it? Okay, so look at found the F table. Okay, look at the alpha. Well, the alpha, you know that it is like 1%, right? That's fine. And the degree of freedoms, go to numerator. So numerator, the top one, right? The formula is n minus 1. So what is your n here? I don't know. What is the n? What is the n? So 21. Okay. 21 minus 1, which is? Okay, let me write it here. Where is it? Where is it? Okay, let me write the steps so that you can see everything. And then your alpha is which is 0.01. This is 1% table. And the degree of freedom numerator, which is n minus 1. Your n is 21 just now, right? 21 minus 1. This is n minus 1. You will get the value of degree of freedom numerator 20. And then degree of freedom's denominator. The same thing, n minus 1. I don't know what is the n. Let me see. 18. Oh, I have changed this equation. That's fine. 18 minus 1. So 18 minus 1, you should get the value of 17. And then you will see your value. Where is the table? Where is the table? Okay, let me put it here. I hope that you can see numerator. So here is 20. Can you see the 20? And then denominator is 17. So from 20 go to 17. Scroll down, 17, 17. What is the value? This one. I hope that you can see this one. 3.16. Can you see that?
Yes.
Yes, hopefully. So this is 20. From numerator, scroll down. You go to 17. 17, 3.16. Okay, so you have to look at two values, the top one and the left one. Okay, so 3.16. So your CV is equals to 3.16. Okay, so then you're gonna draw a diagram. From F is a positive number. You don't have a bell curve shape. You will have something like this. So it's something like this. Okay, it's a positive. You want, yeah, definitely the value is positive. So the CV is 3.16. So it should be somewhere here. This is like 3.16. What is your F just now? What is the value? It is 8, right? We have computed it. It is 8. So F, this is your F. It is inside the rejection region. So you know what should we do, right? So number 5, we have to reject the H null. And then number 6. Number 6. Number 6. You have to interpret it. When you reject your H null, you are saying that, of course, the variance in sample 1 is bigger than the variance in sample 2. So you are saying this, the variance in sample 1, of course, is bigger than the variance in sample 2. That's it. Okay, all the steps are similar. It's just that the difference, because you have different table, which is F, you have to refer to numerator and denominator, and everything is the same. That's it. Anything else you wanna ask regarding this table or whatever? No. Okay, cool. So they also asked me, okay, since we have two things here, like the one affected, not affected by flood, and the affected one, how do we know that? What is the formula for F? Let me put it here. FF. Okay. How do we know that which one is variance number 1, which one is variance number 2? Because we have two things here. Can we put it upside down instead of this is the non-affected by a flood and this is affected? Can we put like the affected on top and the not affected at the bottom? So anyone who can answer this?
I think we should take the higher value.
Okay, cool. Yeah, that's correct. Okay, normally I will tell my student, if you look at the question, okay, which words that you can see first. You want to compare the variation in the selling price of houses that were not affected by flood with the affected one. So you will look at the not affected because this is mentioned first, right? And then if you look at the value here, the not affected housing price is 45,000, and then you compare with the affected 21,000. So normally the question will be designed in such a way they will put the bigger value first and then the smaller value later on first and the bigger later. So make sure that you put the bigger value on top. Okay, so why is that? There is a technical reasons for that. Maybe where is it? Okay, this one. Okay, It says that if you look at this F, okay, so this is something like you have to know. It says that the larger of the two sample variances is placed in the numerator at the top value, forcing the ratio to be at least 1. Okay, normally we will put the larger value on top and the smaller value at the bottom because we wanted the value of f, or we call it the ratio, to be at least 1. Why? Remember, f is a positive number. If you want to draw your diagram, okay, it should be something like this. It should be, so you will have positives and you wanted the f to be 1 and at least 1, and you're going to have all the positive infinity number. You don't want the f to be negative or something, yeah, lower than 0. Okay, that's why you wanted to put the bigger value on top and the smaller value at the bottom. Okay, so anything else you want to ask? I think this chapter is like the most favorite chapter of all because it is easy. Anything else? Any question?
No, madam.
Okay.
Yeah.
Well, well, this basically the chapter is not that easy, but because you are used to look at all these hypothesis question and you get used to it, so maybe that's why you think that it is not that hard. And I also purposely selected the easiest question so that somehow it can help you to boost up your current career marks. Okay, so if you don't have anything to ask, okay, maybe I should stop recording first. Okay, because this is just the announcement.